Okay, guys, I think we can start today's session. This is going to be the last session in this course. Okay, so we are actually completing our course actually. The course was mainly discussing about ROS1, and finally we are ending in ROS2. Okay, if you are good at ROS1, I think this migration from ROS1 to ROS2 is very easy. Okay, uh, so initially when I started working on this course, I think last July or something. Okay, at that time the ROS2 was not very matured. I think Foxy ROS2 Foxy was there, but I couldn't find much packages like navigation. Navigation 2 is there, but it was very difficult to set it up. There are a lot of bugs and all. But when I checking now, I think for this session I was just checking the ROS2 Foxy status. So fortunately, there are a lot of packages ported to ROS2 now, and like ROS1 Noitic, we have many packages in ROS2 Foxy. And in May 23rd, we have a new version of ROS2. Okay, and I think it's almost similar to ROS2 Foxy, but there are some new add-ons. Okay, so that is Galactic. Okay, so you can either stick on to Foxy or Galactic. Okay, I think there are small changes. So, and the good thing is that ROS1 Noitic, then ROS2 Foxy and Galactic will support 20.04. Okay, so that is a good thing. So you can run Galactic or Foxy or Noitic in the same Ubuntu distribution, that is 20.04. Okay, yes. And in the last session, I think maybe I can take the topics that we have discussed in the last session. So these was the topics that we have discussed in the last session. Mainly the basic concept of ROS2. Okay, what was the main difference between ROS1 and ROS2? Okay, I hope you remember about the DDS, the middleware. So I have used a sentence like from ROS1, actually they change the heart. Okay, they change the heart of ROS1 and put a new heart. Okay, so that is the DDS. Okay, so heart of ROS framework is the communication middleware, and in ROS2 they literally change the heart, and there are a lot of other changes happen when we change the heart. Okay, like the communication is more secure, then it's actually product ready, then there are a lot of changes happen. Okay, ROS1 actually designed for research purpose, but ROS2 is actually for products. Okay, I mean both product and research. Okay, so that's a good thing. And we have discussed about the ROS2 concepts. Okay, I think we have compared, like we have literally followed the tutorials. Okay, and if you're good at ROS1, the migration is very easy. You can just go through this tutorial and you can just practice those commands. Okay, then finally we have seen the publisher and subscriber C++ code. Okay, there are some changes in the code. Okay, but again it's actually a good change. Okay, the thing is that they currently we can write a class, okay, for a node. Okay, and we can describe everything inside the class, like all the functions, callbacks, everything. Okay, so it will take some time to adapt this kind of programming, because in ROS1 we have adapted a different strategy, right? But for ROS2 there are some differences, but I think you can compare both. The concept is same. Okay, like publishing, subscribing, all the concepts are same, except some usages are different in programming. Okay, so this was the last topic that we have discussed about ROS2. Okay, I hope you can easily migrate to ROS2 if there is a requirement, and if you're not attending, if you're not present in the last session, maybe you can watch that. Okay, watch that and attend this again. Okay, so in this session I'm planning to discuss about these concepts. Okay, some advanced concepts. Okay, So we have discussed up to the programming part. Now we have to see the URDF, then simulation, then navigation, manipulation, perception. Okay, I'm not going into deep, okay, but there is no need of that because we already seen these things in detail. Okay, so I am mainly talking about the changes. Okay, so initially maybe we can start with the URDF. Okay, ROS2 URDF, maybe I can add it here, URDF, and then simulation in Gazebo. Okay, so in order to learn URDF, okay, there is a good tutorial available. Okay, so there is an examples. So we will get this good example from the ROS wiki itself. Okay, so I'm just sharing the link here. Okay, and I will explain what this tutorial is. Okay, so ROS1 and ROS2 URDF doesn't have much changes. It's almost the same. Okay, the structure of the URDF is same. Okay, tags and all, everything is same. Okay, so you don't need to worry about learning new URDF. Okay, it's the same. So what is different? The difference is like the launch file actually changed. Then yeah, I mean that's all. The launch file actually changed, and what? Then I'm not seeing much changes. Okay, it's almost the same. Okay, so what I'm trying to do here is I'm just setting this package. Okay, there is an existing package called URDF tutorial. Okay, so I have set this package. So they are actually actually showing how to create a new package called URDF tutorial and write your own URDF file. Okay, so that is there. So this tutorial is explaining that. So I am actually taking the ready-made package from here. Okay, and running it now. Okay, then we can see the difference. Okay, so I'm actually doing that. Then we can talk about the difference. Okay, so let me do the demo first. Okay, like showing the URDF in RVs basically, and doing some basics actions using URDF. Okay, so just see this demo. Let me see whether it is working or not. So by the way, when you set these packages, you may get many issues. Like maybe I will talk about that later. Just a second. So we actually running the URDF tutorial. Now I just want to take the ROS2. Okay, ROS2. Then I just want to open the configuration. Okay, so which is inside ROS2 WS, ROS2 URDF, then demo. I think not demo. Let me check. Yeah. So this is the demo. Okay, which is working using ROS2. Okay, and you can able to see it's not the simulation. Okay, basically so what they are saying is this is the R2D2 robot, representation of R2D2 robot, and the URDF is the same, and actually they are publishing the joint states and all from a script. Okay, so in order to move the model in RVs, basically if you can publish a ODOM transform, okay, with the join values and all, it will move like this. Okay, basically it's not the simulation, it's not the value from Gazebo, we are not running Gazebo, but if you have simply the robot model, okay, you can able to publish the transform, okay, TF. Okay, and currently you can able to see we are publishing ODOM, okay, and also publishing some join values. Okay, so it will be moving, it will move like this. That's it. Okay, it's actually moving in a circle basically. Okay, so we have a URDF, it's actually running. Okay, okay, now I'm just getting into the details. Okay, how we can create the URDF in ROS2 and how to run it or how to visualize it. Okay, so this is very important thing, right? If you want to model a robot in ROS, the first thing is creating the URDF. Maybe we have a CAD design and we have to convert into URDF. Okay, so from the URDF tutorial, we will get the URDF here. Okay, so this is a URDF file. So if you just go to the URDF and if you check it, you can find almost same tags. Okay, same tags, joins and links. Essentially it is only having joins and links. Okay, and here they are not using the base link and all, so I'm seeing some differences in the naming. Okay, I'm not sure this is actually the actual naming convention. I think we can use the base link as the the root link, but other than that I'm not seeing any difference. Okay, you can see the base link, instead of base link they are naming it as axis, and there is a leg here. Okay, and there is a leg connect joint which is fixed, so axis to leg is fixed, and there is leg 2 which is also fixed, and there is body. Okay, body is actually moving, it's actually revolute. Okay, and there is a head as well, so head is actually continuous. I think that is what it's rotating. Okay, yeah, that's it in the URDF. Okay, it is not a sacro file, it's actually URDF file. Okay, yeah, so that's a URDF file. And let's check if there is any other things in this package. Okay, so this is the ready-made package. Okay, so in the launch file we have two launch files. Okay, in ROS2 we are using Python script, okay, for launching. Okay, then in resource I think something it's actually blank, and in test I think there are some test script. Yeah, that's it. Okay, there is a state publisher here. Okay, so I will explain the usage. Okay, yes, so other than that, like in the package, it's almost the same. In the package.xml, I think we have seen how the package.xml in ROS2 looks like. Okay, not much difference. Okay, then we have yes, so here we are using setup.py, I think, to make it as a Python package. Yeah, so this is one difference. In this package they are not using the CMake, but I think we can use a regular package, regular ROS package, I think. Yeah, so I think this is optional, this setup.py. So they're saying to install a Python package we have to set it up. So normally if you have a Python module, we have the setup.py, right? So I think we can install this package in that manner. Maybe this I need to check this. I think this is mandatory, I guess. I will check that. Okay, just a second. I will check that. Before that, I just want to go to the launch file. Okay, after that I will go to setup.py. So we have seen the XML file or the URDF file. Now let's see how to visualize it. Okay, how to visualize. So it's a Python script. Okay, this is the launch file in ROS. So this is a main function for launching. We can add any modules here. Okay, and these modules are related to the launch file. Okay, and inside this function we can mention all the stuff, like whether you have to display the URDF, or we have to start the robot state publisher, those kind of stuff. Okay, So starting of the nodes and everything is inside the launch file. Okay. Yes. So inside this function, they actually mentioning the launch configuration. Then they're mentioning the URDF file name here. Okay, URDF file name. And after that, I think, yeah. So after that, you can able to see it's getting the package path and the URDF file. Okay, let me search. Yeah. Yes, it's actually taking this URDF file and its package name. Okay, so the package name is URDF tutorial. Okay, so from this we are getting the path of the URDF file. Okay, then what is happening is here we are starting the robot state publisher. Okay, robot state publisher, which is actually converting the URDF join values to TF. Okay, so for the robot state publisher, we are passing the URDF. Okay, we are passing the URDF, and we have another node called state publisher, so which is actually moving this robot. So you have seen the robot demo, right? Let me start it again. So if you check the demo, the robot is moving, right? Okay, so the movement is actually doing by this state publisher script. Okay, there is a publisher script here inside the URDF. This is a script. Okay, so basically it's using the RCLPY module, okay, ROS2 Python module, and just setting the join values of the URDF. That's it. So I think you heard about the join state publisher in ROS1, join state publisher node. Okay, so in join state publisher, which is helpful to publish the join state values of the robot URDF, and we have the join state publisher GUI as well. So we will get the a window, okay, and there will be sliders so that we can just move the joins of URDF. Okay, so in state publisher, which is actually a custom node, okay, what it does is that it is actually publishing the join states, okay, join values. Okay, so that's why the robot model is moving. Okay, so the movement is doing by the state publisher node. Okay, so essentially in the launch file, if we check it, we have to mention the URDF file. Then we have to get the package name of the URDF file. So from that, we will get the actual URDF path, and we are passing into the robot state publisher. Okay, so this is it. So this is the things that we have to do in order to visualize the URDF file. Okay, so yes, that's it. Okay, so if you check the demo, you can able to see the robot is moving, and if you check the RQT graph, maybe I can take the RQT graph, so you get to know. Just a second. Okay, so this is RQT. Let me check the RQT graph. Okay, node, if you check the node graph, we have the state publisher, okay, which is actually producing the join state of the robot, and then this state publisher, from the join state, it is producing the TF. Okay, so let me check. Yeah, so basically we have the robot state publisher and the joint state publisher as well. Okay, so joint state publisher will publish the joint state of the URDF model, and robot state will be publishing the TF. Okay, very similar to the ROS1. Here they have a custom publisher. That's it. Okay, so you can write your own state publisher, or I think there will be a state publisher, joint state publisher in ROS2. I didn't explore that, but I think there is. Okay, so it will be working like the regular joint state publisher node. So this is the thing that we need to work with the URDF in ROS. Okay, basically we have to create the URDF for Sacro. Okay, and you can just pass like this. Okay, and just pass the URDF into the robot state publisher. Okay, so that so not only robot state publisher, we have to also start the state publisher. Okay, state publisher or any joint state publisher node, so which will be keep on sending the joint values of the URDF, and that will be subscribing by the robot state publisher, and it will produce the TF. Okay, then you can able to see the TF on RVs. Okay, so that is a basic thing in basic URDF visualization and interaction that is happening in ROS2. Okay, so there is not much complexity. There are some changes obviously, and there is a good tutorial that they are using. So in this system I have created a workspace called ROS2 workspace. Then I just cloned the ROS2 URDF tutorial. Okay, I will put this code in GitHub. Okay, our GitHub, and you can able to just launch a file from the demo launch.py. Okay, then I think rvis.launch will start the visualization, I guess. Yeah, I think it will start the visualization. Yes, so that's it. The tutorial, from the tutorial you will easily get an understanding from the tutorial. You know, like they are actually using some URDF from ROS1 because it's almost the same. Okay, it's the same actually. Okay, then yeah, so after the URDF, after creating the URDF, I think we can talk about the simulation. Okay, so again, simulation is almost same. Okay, maybe I can just show you a plain gazebo. Okay, let me start gazebo here. Okay, just type gazebo. Let me see what is happening. Okay, so the gazebo is ready. Okay, similar to the ROS1, the gazebo is ready, and you have to set some environmental variables while working with ROS2. Okay, so I will show you that as well. Otherwise you will get error when you work with robots. So if you have a ROS2 workspace, obviously you have to source it, right? This is how we are sourcing a workspace in ROS2. Okay, I think I have mentioned that in the last class. So basically in ROS2 workspace, when you do the callcon build, it is creating an install folder automatically. Maybe I can show you that. So this is the install folder. Okay, build, install, and log. This is the three automatically build folders in ROS2 workspace. And if you check the install, there is a option to set up the environment. So we can use the local underscore setup.bash. Okay, so this is a script to source the workspace so that we can access the packages inside it. Okay, so this is for accessing the package, and you have to source this script as well. Okay, that is source user share gazebo setup.sh. Okay, this is for setting the gazebo environmental variable. It's actually I think it's very important. Okay, so when you follow the ROS2 tutorial and Gazebo tutorials, this line may be missing. Okay, I also got some errors, so when I checked in internet, I got the solution. Okay, so this is a must when you work with Gazebo. Okay, and also if you have a model path, okay, for example, in home folder, I think you know, right, the .gazebo folder, inside that we have the models folder. Okay, in ROS1 also it's the same. So it will be better to copy all the ROS models or Gazebo models inside it, so that Gazebo will load faster. Okay, so one issue with the ROS2 Gazebo version is that if you didn't have any models inside the Gazebo model path, it will not show anything. Okay, it will be like if you just enter the command called Gazebo, it will be like stuck. Okay, there is no messages, nothing. Okay, but if you do Gazebo, if you just on the verbose mode, you can able to see this message. Okay, so if you have any issue with Gazebo, like Gazebo is not popping up, or if you have any crashes while launching Gazebo, first is check the verbose mode. Check the Gazebo in verbose mode, so you will get to know what is happening in the background. Okay, and currently you can see, okay, it's working, right? And another issue while working with Gazebo is, like, if imagine you are working with a virtual machine. Okay, virtual machine. Currently I am working with the VMware. Okay, so if you are working with VMware or VirtualBox, okay, and when you start launching Gazebo, and if you are getting error or if it is crashed, then you have to set this variable. Okay, it's like it's actually disabling the hardware acceleration. Okay, because in VMware there is no GPU, right? So I think this is actually setting software mode, software acceleration for graphics, I guess. Okay, so if you set this variable like svg underscore vgpu 10 equal to 0, you can just avoid that issue. Okay, so this was also there in ROS1. So this is a must if you are working with virtual machine. So in order to work with Gazebo, these variables are important: svga, then sourcing the Foxy path, it's a must. Then Gazebo model path, also Gazebo sourcing. Okay, so if you do that, the Gazebo will pop up, and we have the gz server and gz client. So same thing, it's the same thing. So the Gazebo will pop up. Okay, yes, there is no difference. I think the version is the same, 11. Yeah, it's 11.5. Okay, yes. Now if you just want to launch the Gazebo in ROS run or ROS launch, we have the ROS launch file called Gazebo empty world or something, right? So if you want to launch from ROS tools, we can do that, like ROS2. Okay, this is a keyword first we have to enter, then launch. Okay, then there is a package called Gazebo ROS. Okay, so same as ROS1, and inside that, if you press the tab twice, you can able to see gazebo.launch.py. Okay, just give it, and you can able to see it's actually starting. Okay, so it's a Gazebo ROS launch, okay, using ROS launch file, ROS2 launch file. Okay, it's the same thing, there is no difference. Okay, so this is a command, ROS2 space launch, then the package name, the Gazebo ROS, is the same as ROS1, then gazebo.launch.py. So when you press the tab twice, you can able to see the launch file like this, gz server.launch.py. So all the launch files are here, so just launch it. Okay, so this is how you can just start with the Gazebo. Okay, yes, so I think that will be enough to get started with ROS2 and the simulation. Okay, so if we are discussing the navigation and move it, I will show you how to set the other things. Maybe while discussing the navigation, I will explain some more concept related to the simulation. Okay, so in order to work with the URDF and simulation, I think this much concept is enough. Okay, almost all the things are the same. We can use these commands to work with Gazebo. Okay, so now what we are talking is how to create a simulation. Okay, create a new simulation using ROS2. Okay, and create the navigation stack, setting all the navigation stack, and do the autonomous navigation. Okay, so in this case also the better example is Turtleboard 3. Okay, so Turtleboard 3 in tutorial we have the navigation demo. Okay, so I'm using the Turtleboard 3 as a reference here. So you can able to check Turtleboard 3 ROS2. If you just search, you will get to get the manual of the Turtleboard 3. Okay, using ROS1 and ROS2, and we also get some good tutorials from Ubuntu. Okay, this is also good, and luckily this tutorial is also based on Foxy. Okay, yes, so this is the tutorial. Okay, so I will show the tutorial and I will show how to set it up. So before that, I'm just giving you the reference. So from the e-manual of Robotis, okay, there is a simulation tab. Okay, Gazebo simulation. Then you will get an option which version of ROS you want to use. Okay, so if you just select Foxy, you will get the tutorial for setting the simulation. Okay, so Turtleboard 3 simulation is the reference for creating a new robot, new simulation robot based on ROS2. Okay, let me take its repository. Okay, so Turtleboard 3 repository, and if you check, there is Foxy Devil, okay, and Galactic Devil is there. So I'm just giving the reference, so you can able to see all the things. Like they are actually using the cartographer. So ROS2 is having the cartographer package for SLAM. So we have the Turtleboard 3 description. So you get to know how to create a description package from this example. Okay, then yeah, so you can able to see the URDF file here. Okay, URDF file. Then meshes here. Okay, yes, so, and if you check the navigation too, it's all related to the navigation stack. Okay, so they have configured the navigation stack and the cartographer, the SLAM. You can follow this. Okay, I'm just saying this because it's very easy to do, because you already done these kind of stuff in ROS1. Okay, so I'm not explaining in detail. Okay, you can simply follow this repository in order to work with a new simulator robot in ROS2. Okay, so let me start with the simulation of Turtleboard 2. Okay, after that I will explain what is happening. So first so imagine you want to work with Turtleboard 3. Okay, so one option is you can clone the this packages from the GitHub, or the simplest way is just take Synaptic. Okay, just take Synaptic Package Manager and search for Turtleboard 3. Okay, so if you do that, you can see the binary packages of Turtleboard 3. Okay, so you don't need to clone these packages and all. Simply install Turtlebot 3 packages, all these packages. Okay, you can just skip the debug binaries. Rest of the things you can just install. Okay, so I have installed all the stuff. So even you can work with Turtlebot 3 with webbots, okay, which is a very good simulator. Okay, so you can install all these things. Okay, simply after that you can simply launch the Turtlebot simulation. Okay, we have the command here. Okay, so the package name is turtlebot3_gazebo. Okay, so now just copy paste. So you can able to see the command here. Turtlebot3_gazebo is the package, and inside that we have a launch file called empty world. Okay, so now the Turtlebot 3 is popping up. Okay, but compared to the ROS1 Turtlebot 3, here they are only using plain meshes. Okay, it's not very detailed, but if you remember in ROS1 when you worked, it was very detailed. Okay, I think currently they are only using plain meshes like this, and that is actually enough. Okay, that is actually enough for the simulation. Okay, okay, so we have started the Turtlebot 3 simulation. Now you can play with it. Okay, now you can play with it. Just check the topics, ROS2 topic list. So you can able to see the command velocity. Okay, and if you just want to control the robot, you can publish the command velocity, right? So just take the RQT, and these are the nodes that is currently running, I guess. So let me close this, and I'm just starting the robot steering plugin. Okay, so you have to install it from the Synaptic Package Manager. So if you just check steering in Synaptic, you will get the RQT robot steering plugin. Okay, so now Foxy is having a lot of packages. Okay, so I think you can currently you can start working with ROS2 because the package support is very huge now. Okay, so you will get almost all the packages for ROS2. Okay, so we get the steering plugin in RQT. Now just move it. Okay, just move it. And if you just want to put any obstacle around it, can put it. Okay, and I just want to visualize the laser scanner. So ROS2. Okay, and let me open the ROS config. Okay, I think I'm not sure the ROS config. Maybe let me use some existing configuration. Just a second. They may have some commands to start some ROS with some configuration file. Let me check. Yeah, I think this. Let me try. ROS2 launch. Turtlebot 3. Then on the bring up, there is ROS2 launch. Let me check whether okay, I think this is the thing. Okay, yes. Okay, so you can able to see the Turtlebot 3 here, but I think the visual meshes are more textured. Okay, but simulation meshes, I think they are using the collision meshes, I guess. Okay, so you can able to see the laser scan in ROS. Okay, like you can just set it up like okay, you can see the transform. Okay, so in order to visualize the robot, we have a launch file called turtlebot3 bring up. Inside the folder there is ROS2.launch. Okay, so you can able to visualize the robot, and at the same time, if you want to control, you can use the RQT steering plugin. Okay, and by the way, in ROS2, actually the ROS parameter, right? ROS parameters are like dynamic reconfiguring parameters. Okay, if you remember the dynamic reconfigure parameters in ROS1, it's actually like the parameters that we can change dynamically. Okay, so in ROS2, by default, all the parameters are like that. Okay, so here you can able to see the robot model, then the odometry. Okay, yes, so this is the turtlebot 3 simulation. Okay, let me close this, and let me show you how to start the navigation, okay, using the simulation of turtlebot 3, and there is no difference. Okay, the steps are the same. Okay, and after the demo, maybe I will explain about the ROS2 navigation stack, okay, in detail. Okay, so first we can start the turtlebot 3 simulation. Okay, we have the package called turtlebot 3 gazebo and the turtlebot 3 world. Okay, that is the launch file. So just copy paste. Okay, so when you work with the turtlebot 3, I think you know you have to set the turtlebot 3 version or the name. Okay, so you have to just export turtlebot 3 underscore model equal to burger or waffle. These are the two models available. So then only it will work. Okay, so this is exclusive for turtlebot 3. Okay, not for other robots. So let me start the world file. So we are actually trying to do the navigation. Okay, navigation involves first the mapping, then the autonomous navigation. Okay, so first we have started the simulation of turtlebot 3. Okay, the same turtlebot 3 environment that we have seen in ROS1. Okay, now what's next? We have to start mapping, right? We have to start mapping. So for mapping, we are using cartographer. Okay, I think you heard about the cartographer. I already explained about cartographer, Google cartographer package, which is very good for mapping the environment. Okay, so you can easily launch the cartographer launch file from the turtlebot 3 cartographer package. Okay, ROS2 launch turtlebot 3 cartographer.launch.py. Okay, then also setting the simulation time equal to true. Okay, now starting the cartographer. Okay, so when we start the cartographer, it seems like it's building the map. You can see a rough mapping. Okay, now what's next? We have to map it, right? So for that, we have to start the teleop. Obviously, we have to start. So there is a package for doing the teleop, turtlebot 3 teleop. Okay, just start here. Okay, so it's here. Now we can simply move the robot. You can able to see the robot start moving, and can just move it around. Okay, you can simply try to, oh, it's hit the wall. Okay, 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 it's actually building the map very fast. Okay, so robot is here. Okay, now I'm just moving and you can able to see the map is building. Okay, okay, okay. So I think you can see the map is getting building, right? Yes, yes. So now we can save the map. Okay, after creating the map, you can save the map using this command. Okay, we have a new package in ROS1. It was map server, right? But in ROS2 it's nav2 map server. Okay, inside that we have a node called map server underscore CLI. Okay, in ROS1 it was map server only. Okay, and after that we can just mention the path. Okay, so I already saved the map in home folder, so I'm not doing that now. Okay, I can show you the created map in my home folder. So this is the map that I already created. Okay, yes. So now what's next? The navigation, right? Autonomous navigation. So let me start the navigation. So first we have to start the simulation again. Okay, so just copy paste. Okay, yes, so we have started the simulation. Now what's next? We have to do the navigation, right? So there is a package called Turtleboard 3 navigation 2. Okay, inside that there is a launch file. So just mention our map as well. Okay, now start the navigation launch file. Okay, it started. We have the RVs, okay, with the map. Okay, yeah, that's it. Okay, so in order to start, first we have to initialize with the 2D pose, okay, of the robot. So you can set it here, rough pose of the robot. Okay, you can manually set the pose, okay, if the pose is not correct, and after that you can simply do the nav goal. Okay, so it will create the path, okay, and it will do the navigation. Okay, it's almost the same in Turtleboard, ROS Noetic. Okay, I found this navigation stack is much better than ROS1 navigation stack. Okay, maybe when we start explaining the concept of navigation 2, then you will understand the blocks of nav2. Okay, it is having a lot of features. But if you know the navigation stack 1, then you can easily configure all this stuff. Okay, basically setting the navigation stack and all, there is no code involved. It's all like using our logic. We have to set some configuration files and launch files. Okay, that's it. Okay, so now we are working with the navigation 2 from ROS2. Okay, yes. So let me close this and let me explain about the new navigation stack. Okay, navigation stack 2. Okay, so maybe you can take this website, okay, official website of navigation stack 2. Okay, and we can able to see what are the new things, okay, inside the navigation stack. Just a second. Open. Yeah, I think. Yes. So this is the architecture of new navigation stack, and by the way, this is official website, and you will get all the information about navigation stack 2 from this website. Okay, there are installation instruction, but to install, I think you can use the Synaptic Package Manager. Okay, navigation 2 will be automatically installed. Okay, now we just want to see the difference. Okay, I think you already aware of navigation stack 1. So what are the differences in navigation stack 2? So it will be better if I take the navigation stack 1 navigation stack architecture. Okay, yes, this one. Okay, let it load. Okay, or this one, or anything. Yeah. Okay, so this was navigation stack 1, right? So inside that, like we said that there's a move based node, and inside that we have global planner, local planner, recovery behavior, and the input to the move base is the odometry, then TF, then map, then sensor sources. Okay, sensor topics like laser scan and point cloud, and the input to the move base is the goal position. Okay, and the output is the output from the local planner, which is the command velocity, twist messages, okay, which is going to the controller. So this was the working of navigation stack 1. Okay, what about navigation stack 2? So we have the navigation to pause. Okay, on the top you can able to see it's a waypoint basically. Okay, so there are a set of waypoints. Okay, and that is feeding to a BT navigator server. Okay, BT stands for behavior tree. Okay, and I think you have some idea about the behavior tree and finite state machine. Like if one state is occurred, based on the success, it will switch to another state. Okay, so if you just compare with behavior tree with the finite state machine, I think the behavior trees are much better. Okay, so in many aspects. So in navigation stack, they are using a behavior tree navigation server. Okay, so you can put all your like configurations and all the checkups, all the like conditions and all in the behavior tree as an XML file. Okay, so one of the input to the navigation stack 2 is an XML file. Okay, which is having all the behavior tree stuff. Okay, and other things like TF transform, map, these things are the same, and sensor data is there, point cloud to or laser scan, that is the same, and you can able to see the local course map is generating the command velocity to the base controller. Okay, so mainly the BT navigation server is there, and also all the things like recovery server, control server, planner server. Okay, these all are servers now. Okay, and also we can create plugins on it. Okay, and the BT navigation server is communicating to all of this. Okay, so we have the course map, recovery server, then planning plugins, that is for global course map, then control plugins. So there are different set. Okay, so currently the new architecture is this. Okay, I think the scope of the navigation stack 2 is very big. If you just remember the navigation, navigation flex, right? I think nav flex or something. Move base flex. That was one of the package that we have discussed, which was maybe I can take that package. So this is an advanced or modified version of move base. Okay, MoveBase is basically navigation stack. So here we can able to see the action. It is actually exposing each modules in the navigation stack to the action server. Okay, but here it's actually like much better. You can we can make use of all the parts of the navigation stack too, based on behavior tree. Okay, rather than working with the ROS actions, we can easily work using the behavior tree. Okay, and maybe if you want to explore the code based on behavior tree, I think again the Turtlebot 3 code will be better. So I think in navigation 2, let me check yeah, I think this is not having much things, I guess. Yeah, currently in Turtlebot 3, I guess there is no behavior trees, I guess, but we can load it, okay, if you want. Okay, so it will be working based on the behavior tree, I mean the instruction that we are given. Okay, so it will be better to start with the Turtlebot 3 packages, and yeah, and for getting the tutorials of behavior tree, everything is here. The XML usages, everything is mentioning here. Okay, you can mention all the logics in an XML file. Okay, yes, so this is navigation stack 2. Okay, the new navigation stack for advanced applications. Now we have the MoveIt 2. Okay, MoveIt 2, which is, I mean, almost the same as MoveIt 1, but it's actually ported to ROS2. That's it. Okay, from my understanding is that that's all what happened. So there may be slightly some differences, I guess, but I found it's almost the same. Okay, so if you want to install MoveIt, you have to build it from the source code. Okay, there is no binaries available. There is few binaries available for MoveIt, but it's not the core packages and all. So they have the instruction to compile the MoveIt packages. Okay, so you can just follow it. Okay, it will take some time. Okay, after that you can, I mean, it will work. Okay, so this is the instructions. Okay, there is not much complication, like it's saying to create a workspace and just cloning all the MoveIt 2 packages into it. Okay, and after that it will work. Okay, so the MoveIt is ready. So if you want to do some demo using MoveIt 2, maybe I can show you that. It's a similar stuff. If you just search for MoveIt tutorial, MoveIt 2 tutorial. Okay, yeah, here this is official tutorial from MoveIt. Okay, so you can just change the version here to Foxy and ready to go. Just follow after setting the MoveIt in your computer, just follow the instructions. Like if you just want to work with the Panda robot, this is instruction to set the MoveIt and MoveIt tutorials. Okay, so after that you can work with it. I can show you the example using the Panda robot. Okay, so you have to add the motion planning display type. So the same motion planning plugin. Okay, there is not much difference. We have the robot here, and if you change the hand to Panda arm, we got the marker, interactive marker. So just move it, then plan and execute. Okay, it's the same thing, right? Okay, yes, Currently it's executing in the fake controllers. Okay, so this is MoveIt 2, okay, with an example. So there is not much differences as per my understanding. You can simply follow this tutorial like ROS1. So just change into Foxy and just follow the steps to install MoveIt and set these things to see the example. Okay, so I'm not explaining in detail, it's almost the same as ROS1. Okay, yes, now I just want to show you the perception stack, that is basically the images, okay, USB cam and all. So how to work with the USB cam in ROS2. Okay, let me close this stuff. So let me show you that. Okay, so we can see how to work with the USB cam. Okay, yes, so I'm working from the VMware, so I just want to add the camera. Let me check. Okay, I'm just connecting. Okay, seems like it's connected, and I'm just checking using the Cheese application. Seems like it's working. Okay, this is me. Okay, so currently the camera is working. Okay, so if the camera is working, then we have a package in driver package in ROS2. So just search for v4l2. so you will get a package called ROS Foxy v4l2 camera. Okay, just install it. Okay, and just run this node in order to start the driver. So the camera is ready. Now using RQT, you can simply visualize it. Okay, so you can able to see the image. Okay, so you can see the image topic from here, ROS topic list. So the topic is image row. Okay, ROS2 topic info image row. So you get to know it's sensor message image, and there is only one publisher and subscriber. Okay, yes, so also like ROS2 node list, there are 3 nodes working. Okay, v4l2 camera is the driver node. Okay, so now if you want to process this image, okay, I just closed it. Process the image, we have the CV bridge. Okay, CV bridge ROS2. Okay, so I don't have the code right now. Okay, so if I get it, I will put it. So using CV bridge, you can see it's CV bridge ROS2. I think this code will work. So using CV bridge, you can able to get the images from the camera driver and convert into OpenCV format, and you can process it. Okay, so this is a way same logic. Okay, some APIs difference will be there. Okay, so I think we have gone through the navigation, MoveIt, then the perception. Okay, now there are some extra packages. Maybe I can show that as well. PlanSys2. It's PlanSys2. Yes. Okay, so this is actually a good package for planning. Okay, planning, they're saying they have an AI PDDL based planning system. Okay, and it may be good for mobile robots. Okay, not only mobile robot, any kind of robot, I guess. Yeah, so I didn't explore this package, but I just want to show you this. Maybe there are many demos, so you can just go through it. Okay, so actually in ROS1 there was a package called ROS plan. Okay, so I think this is a ROS2 version of ROS plan. So this was ROS plan, and yeah, so this is the ROS2 plan. Yes, and another thing is SLAM toolbox. Okay, I think we have explored SLAM toolbox in ROS1. It is also there in ROS2. So the advantage is that it's actually a complete toolbox for mapping, then editing. Like it's based on the Kato SLAM. Okay, Kato is actually like they created this new SLAM for products. Products. Okay, so it should cover a big area actually. Okay, so that's why Kato SLAM is using like to map a big environment. Okay, so it's apt for that kind of applications. You can able to see it's actually mapping big, and using SLAM toolbox you can just pause the mapping and add it. So a lot of things that we can do. Okay, so it is compatible with ROS2 now. Okay, yes. Yes, other than that, let me check. Yeah, so these are the things that I want to convey, and from the ROS2 tutorial, okay, documentation, I think there are a lot of stuff that we have to explore. Okay, I'm still not explored all the aspect of ROS2. What I did was I was just comparing ROS1 and ROS2, and my plan was to convey that almost all the things are the same. Okay, so that you will get a grip on ROS2 as well. Okay, not only ROS1, and then you can easily migrate to ROS2. Okay, so all the tutorials and everything is there. So I think this session will be a spark to you, okay, to get started with ROS2. Okay, I'm not planning for taking a detailed session on ROS2 because that is a wastage of time, because we already seen this stuff in ROS1. So if you are a beginner, I think it makes sense that like taking all these things once again. But for you already like mastered the ROS concept, so for you I think it's like just compare the stuff and show how the migration can be done. Okay, so now we can do the Q&A session. Okay, if you have any doubts you can ask me. Like I'm still exploring a lot of things in ROS2, so if I don't know anything, maybe I can get back maybe after referring. Okay, so just let me know if you have any confusion in today's sessions. Yeah. Okay, so yeah, if you don't have any confusion, I think we can conclude. Okay, so this is the last class of our course, and after this I'm planning to do a convocation, whoever complete the course, we can like do a convocation virtually, and I can distribute the certificate online. And yeah, and I will be here on this group. Okay, and you can ask question if you have any, and all the materials like the GitHub and everything will be there. I will not delete or remove the access. Okay, and the Discord will be also there. Okay, you can refer it. Yeah, all the content will be there. Okay, and regarding the interview, maybe you can try to solve the problem that I have shared to you, that is self-driving car problem and pizza making robot problem. So after that, if anyone complete that, we can arrange a personal interview. Okay, so that I can ask you questions related to ROS, and I can just gauge your understanding about it. just to understand. So you will also get to know how much things you know, basically. Okay. Yes. So thanks for listening, guys. I will be here. I will be here in Discord always. Okay, you can ping me. And after this course, I am planning for like short course, like crash courses, maybe related to ROS2 or related to ROS1. So if I'm coming up with some short courses, I will put it in the Discord channel. Okay. So if you are interested, maybe you can just enroll. Okay. Yes. So thanks, guys. Thanks for listening. Thanks for enrolling to this course. And I will be starting distributing the certificate. So give me some time. Okay. I just want to plan because whoever enrolled to this course may not complete the course. Okay, so I'm planning to give the certificate to those who are completed or who are having good idea about ROS now, and after that maybe I can give others certificate as well. So I didn't plan it yet, but I will let you know. Okay. Okay, guys. Bye, everyone. Yes. Bye.